So good morning, everyone, and welcome to today's Sacco System webinar. So the goal of the webinar of today is to illustrate some mechanisms that are behind the coagulation of the milk. And I would like to explain how the enzymes and the trace elements inside the rennet act to create the curd. So my name is Luca Zucchi. I've been working in a company, in a lorry company, and I was directing the traffic office until 2001 when I joined Calificio Clerici, where I worked as an area manager in northeast of Italy and Parmigiano Reggiano area until 2018. Since when I started in the export unit, and in 2019, January, I became a project manager for the enzymes until now in West Europe, Central Europe, and some countries of the Middle East. Let's talk about Sacco System. What is Sacco System? It's an international biotech excellence applied to food, nutraceutical, and pharmaceutical industries. The slogan, supporting food culture and life, is a communication of our companies to support the culture of food, health, but also to develop cultures for food and health, also for humans and animals. What does system means? It expresses the extraordinary synergy between our companies, Calificio Clerici, Sacco, Centro Sperimentale del Latte, and Chemicalia. Every one of our companies maintain the proper characteristics and the productive specificities, for every company. Sacco is an Italian family-owned company and offers a large range of innovative products, from starters for food fermentations to nutritional supplements, such as probiotic cultures, as well as instruments for food. The sister company, Calificio Clerici, has been an Italian leader in rennet production since 1872, and in 2006 acquired the Swedish company Chemicalia. Sacco, furthermore, acquired the Italian culture producer CSL, Centro Sperimentale del Latte, in 2013. So the family company tradition and expertise, creative intelligence, reliability, research and innovation invested 6% of its turnover in knowledge sharing, flexibility and customization, and also research and development. Sacco System has 7 production plants and sells in more than 110 countries worldwide, through a network of agents and distributors, which are characterized by high professionalism and generating in 2018 a total turnover of 108 million euros. More than 50 research and development collaboration with universities and technical centers around the world, and collaborators coming from over 20 different countries in the world. So let's see how the contribution of animal rennet acts in the transformation of milk. Here are some numbers. They are so huge that it's almost difficult to read sometimes. We have around the world over 300 million dairy cows with a total production of over 700 million tons of cow milk, which means that every cow produces at least 2,400 liters per year. And the cheese obtained by all these numbers is summarized in 70 million tons of cheese. So the definition you can see on this slide is according to legislation of Italy, and it defines the cheese as obtained from the milk coagulation following acid or rennet coagulation. which is very simple to understand. And we have two kind of coagulations, such as the prosamic coagulation, which is the most widespread because we can imagine that in Europe especially, there are a lot of DOP or PDO, AOC products, and they required specifically the coagulation, the prosamic coagulation made with animal rennet. But the coagulation is possible also with coagulants, and they are different from the animal rennet. We can see specifically the caseins that are contained into the milk. Caseins are very fundamental in coagulation. And if we go to analyze the various type of casein we can find, we see a greater presence of alpha and beta caseins and K casein, which is the one with the less presence into the milk. Alpha and beta caseins represents the parts less similar to the liquid phase in which they are dispersed, like milk, for example, because they are more hydrophobic and result insoluble. But this is where the K casein comes into play, because also, and although the presence is smaller, is the one that allows the entire family of the caseins to exist in the suspended phase inside the milk. That's because the K casein has about 5 glucose groups inside, and they are very hydrophilic. And in addition, these groups are arranged into the terminal part of the caseins. And it means that the K casein has the ability to orient itself and arrange itself into space, into the milk, to protect also the other caseins. So this is very fundamental, not only for the existence of the casein itself in the milk, but also because it starts the coagulation process. And this is just the beginning to obtain our cheese. Now we can see why. Sorry, okay. So the caseins are arranged in space like in the form of a micelles. This is the most stable arrangement, which therefore allows balancing and repulsion and attraction forces. Due to the incompatibility between the hydrophobic parts of the caseins and the aqueous phase of the milk. And for this reason, the K casein, and we can see like a filaments, like beads in this picture, are arranged mainly on the outside, directing that hydrophobic and hydrophilic part towards the aqueous phase. And it's acting like a float for other caseins. This allowed the micelles to be floating also in the milk. And to maintain this balance, the submicelles, which they tend to aggregate, are connected by bridges of calcium phosphate, which keep distances between them and avoids to collapse on themselves. And this is where rennet really has a specific and very, very important role. What is rennet? Rennet is a natural enzyme complex and other elements like oligopeptides, for example. We find two families of enzymes, the most useful one, which are kinesins and pepsins. In our case, I'm talking about clear rennet, we can find all the enzymes present in nature. and that's very important for the coagulation. We can find three kinds of chymosyns. I will show in the pictures the A, the B, and the C, and 7 types of pepsin, which go from type A1 to type A6, and also the pepsin B, always shown in the picture here. The way these enzymes act inside the milk is different. And this is a very important reason that allows us to choose the rennet that has an enzymatic composition. This is most suitable for the type of the milk and the process of cheese making that we want to carry out. But how can we choose the right rennet for our productions? Let's talk first about the composition. Composition is a ratio between the percentage of chymosin and pepsin contained into the rennet. For example, as you can see here, if we're talking about 75-25, the intention is that 75% is the composition of chymosin and the remaining 25 is pepsin. So this balance, or these parameters, affect the residual proteolytic activity that we find in our finished product, so the cheese. So chymosin is very important to study coagulation because it's affecting the activity on the 105 and 106 residues of the casein, allowing the micelle to aggregate. Obviously, high level of non-specific proteolytic activity can lead to formation of medium-length peptides, and this can result maybe in a bitter aftertaste, which we don't want into our production. More pepsin, on the other side, will have a more generic proteolysis in various points of the casein system. This is meant as the result of a richer whey or higher residual proteolytic activity in the cheese, with different repercussion of the texture, including softer consistency or greatest advancement in maturation in our cheese during seasoning. But how can we measure the strength, how we define the strength of the rennet? So Calificio Clerici uses the only and official measurement method, which is IMCU. IMCU stands for International Milk Protein Unit, and it is the coagulation activity required to coagulate 10 milliliters of substrate in 100 seconds. So the substrate, what is composed by 10.7% of reconstituted milk powder in a 1.01 molar aqueous solution of calcium chloride with a specific pH, which in this case is 6.35. Generally speaking, all the things being equal, the higher concentration of enzymes, the higher the speed, the consistency and the elasticity of the cloth. For the reason, we usually use rennet powder for our cheese with high IMCU values. But the important thing is to choose the rennet based on the processing and the raw material that we have to work with, because a stronger rennet is not always the right choice or the most suitable for our production, because the right balance between the strength and the composition should be found following everyone's need. And the rennet type must be adapted to the type of milk and not the milk adapted to the rennet, which is quite impossible. In other words, milk plus rennet equal curd plus whey. which is very simple. This is how the rennet transfers the milk. Well, how is rennet acting to get through the curd? First of all, we have the phase one, which is very, very important, is where the chymosin hydrolyzes the bonding position 105 and 106 of the casein and let's free the soluble part of the glycomacropeptide. So without these parts, the micelles is destabilized. The casein can go no longer and remain in suspension and fall on themselves. So phase two and phase three instead is about chemistry. Because in this phase, the caseins are now insoluble and they're precipitated, reorganizing themselves, joining, becoming one. This occurs through the formation of calcium bridge, which are obtained by exploding the new site, the space that these micelles has in the milk, and they free the hydrolysis of chymosin. And the results is the formation of a complex lattice that will appear like a gel, and this is the curd. Here we are. This is a photograph, the yellow in the left corner, bottom left corner, is obtained by using an electronic microscope, and we can graphically observe that the arrangement on the space of the micelles change, going to create a tridimensional lattice. So it is the yellow part you can see on the picture. Inside, we can see, we will find not only the precipitated protein part, but also everything that was found in this reaction. In the curd, we will have part of the components that were in the emulsion or solution of the milk, like fats, sugars, and other proteins. This is clear, quite clear from this picture. And which are the factors that influence the curd? First of all is temperature. Temperature regulates the reaction speed and the enzymatic and chemical phases inside our milk. Each type of processing, based on the product that we want to obtain, has an optimal temperature range. The second one is the pH. It regulates the balances of the salts inside the micelles for the temperature, for example, each and every process has its own pH range in which to operate. And then we have the type of rennet, which is determining the enzymatic hydrolysis and the post-coagulation residual activity, which is very important. The milk composition, because it depends on the constituents of the milk, including calcium and proteins, for example, are very influencing the curd. The bacterial flora, the type of bacteria of starters inside the milk, is going to determine how important are the variation in the acidity, in the aroma, and the texture of the final product. And the presence of unwanted bacterial flora, which can lead to serious problems and defects in the finished products, in the cheese. But also timing and methods of cutting the curd is very important. Because the precise time and the method of cutting the curd is fundamental to block the aggregation reaction, and here is where we find what really is inside the finished product. Of course, every product has its own parameters, and the ratio between the firming time and the total time must always be respected to achieve the best results. The revealing time of the coagulation phase are mainly two. One is the setting time, so the time that elapses from the introduction of the rennet into the milk until the first appearance of the flake, of the flocule. And the second, important, is the hardening time, so the time that elapses between the setting time and the cutting of the curd. So on a practical level, there are no common times for everyone, because every kind of cheese, every kind of production is different. But there is just a guideline we can give to the cheesemaker to be followed. So, scientifically speaking, to identify the correct cutting time, we should use instrumental. We should have instrumental analysis, which are necessary to determine the right time of cutting. And this is how the variation of setting time, what do they lead? We see the increase of protein content on the table on this slide. So increasing setting time, we have more proteins to hydrolyze and more steric hindrance, which hinders the reaction speed. So increasing lattice creation speed. Once precipitated, the proteins will be more, and this is going to favor the creation of the lattice. Increasing the lattice firmness. More proteins means having more substrate to build, and the three-dimensional protein lattice that we saw on the picture. Increasing in structuring salts. The calcium in solution lowers the pH and favors the enzymatic cut. Increasing in lattice creation speed is the intramicellar calcium favors the creation of calcium bridges between the caseins. Increasing the lattice firmness is a lattice with more calcium bonds and also more firm and structured lattice. The cut of the curd. So as we were talking, choosing the right moment to cut the curd is very, very important. So the ideal moment is the one that allows you to have the right amount of fat, sugar, and proteins trapped inside the lattice, which give more cheese. These quantities are influenced by the conformation of the lattice, which will also influence the permeability respect the bleeding of the serum, of the whey. With an early cut, we have a nutrient-poor clot and a weak casein network. Very fragile, and with an uncontrolled syneresis. On the other side, with the late cut, we will have a right lattice too much rigid, too hard, with a difficult syneresis. This is why the right moment has to be carefully chosen. the right moment of cutting, of course. In processing, for example, the hard cheese or hard cheeses in general, with long seasoning, we will have a card that is at the end of the cut will have the size of many rice grains, for example. And this is why we need to maximize the way purging and the dry of the graining resulting. This is the last slide I would like to show you because nowadays it is more common that people would like to try and have something that they are going to make on their own at home, for example, which is quite easy to achieve. These are the ingredients and the materials, all the tools you need to achieve the best results. Of course, the rennet is just an indication. Instead of lemon juice, you can use cultures that we are always and also providing. I think the simple way is to use some lemon juice to lower the pH. And to the people listening who would like to try this one, please feel free to gather all the necessary ingredients and tools and have a look at the results. So I would like to first thank you once again for the time you spent with me during this webinar. If you have any question, I will try to answer you right now. Otherwise, you can reach me in my business email. You can see in the slide on the screen. I can just always suggest you to check our website and see what's going on, which other webinars are present during these days. And you will find the Q&A box somewhere on your screen. Here we are. Okay, talking about temperature. Is temperature influencing the life of rennet? Thank you very much for asking me. Yes, it is. So once we produce rennet, we always suggest to keep in a cool storage in a range that goes between 4 and 8 degrees Celsius. This is why casein, which is very thermosensitive, don't need to be stressed. And we would like to keep for the whole life of the rennet as active as possible. This is why a cool and dry place is recommended. Has rennet an expiring date? Yes or no. Yes and no. We are talking about a term of consumption, even if we are not eating rennet, of course. But it's meant to be by the law that we have to indicate an approximate date, which we are studied a lot in our company, until which the product is stable. So, I make an example. For the liquid rennet is 6 or 9 months, depending if it has preservative inside or not. And for powder rennet is 1 year. It means that after these dates, the product is not harmful for the health. It's just starting to decrease its values. For example, casein will no longer be 75%. It will be something less. IMCU, which represents the strength of the Rennet, for example, 110 will be no longer that. It will be instead 100, for example. It means that to reach your aim, you have to add a little bit more product inside the milk, but it's not harmful. Other questions? Okay. Thank you for asking. This requires a little bit more time to answer. I'm very sorry, but I suggest I will keep note of this question. And if you reach me to my business email address, I will surely give you an exhaustive answer. But I'm sorry, it's going to be a little bit too long for the webinar. But I will surely answer you. Thank you very much for contacting me. Okay. Once again, thank you very much for joining us, and we will see you to the next webinar on saccosystem.com. Thank you very much.